Hi guys, today's lesson is on how to express algebraic fractions as the sum of two partial fractions. If we have a look at this expression over here, we see that we've got an expression x squared minus 2x minus 15 in the denominator and 2x minus 26 in the numerator. Now it's possible to express this rational expression or fraction expression as the sum of two separate fractions. And the way we do this involves a technique that we introduce values for, or pronumerals into, and solve for those pronumerals. And this technique works with just about every rational expression or every fraction expression made up of algebraic terms. So let's look at how this works. The first step is to factorize the denominator of the rational expression. Now our denominator here is a quadratic expression and it does factorize by inspection quite easily. Sometimes it might be a cubic expression or even a higher order polynomial. But the first task is always the same, and that is to express the denominator as the product of its factors. So we must therefore factorize. So let's do this. We'll take our original expression. I've done nothing to it, we're just copying it down for the sake of clarity. And now we notice that the x squared minus 2x minus 15 has two factors which multiply to 15, being a 3 and a 5, and add to negative 2. Now that means the 5 has to be negative and the 3 has to be positive. Just once again checking, positive 3 and negative 5 add to negative 2 and multiply to negative 15. So we've factorized the denominator of our rational expression. So that's the first step. The second step is to, and this is the key one, to express the fraction as a sum. So even though we've factorized it, we're going to express it as the sum of two parts, each being with a denominator equal to one of the factors that we managed to obtain when we factorized this expression. Had this been a cubic expression, we would have had a third term, plus c over whatever the factor would have been. There are more complex cases of this, where for instance we've got a cubic and it factorizes into a linear factor and a quadratic factor. We'll have a look at that in a second video on how to deal with quadratic factors in the denominator. But for this one, we're assuming that it factorizes into linear factors, that is, no x squareds, just plain x's. So there are two possible numbers for a and b which would make this expression true, and our task now is to determine what they are. So that becomes step 3. Determine the values of a and b for which this expression would be true, because once we've done that, we've actually solved the question. We've expressed it as the sum of two fractions, the two fractions being these two parts with the values of a and b substituted in. So the technique's fairly straightforward. What we do, starting again with the previous line of working, is we work out the lowest common denominator of the x plus 3 and the x minus 5 denominators, and whilst we don't know the value of x, we can be guaranteed a common denominator would be simply multiplying them together, x plus 3 and x minus 5. This is a little bit like having a common denominator for something thirds and something halves. It would be something sixths. The sixth would be a 2, that is the halves, multiplied by the 3, that is the thirds. Multiplying two denominators is a guaranteed way of finding a common denominator. Now whether that's the lowest or not, we don't know, but in the case of x being an unknown, it's the lowest one that we can be sure will be a common denominator. So now we've done this, we express this right hand side as a sum of two parts itself as follows. That is, we write it all over one common denominator, and at first this might seem like we're going backwards in our working, and we say to ourselves, well, in order for x plus 3 to become x plus 3 times x minus 5, we had to multiply it by minus 5, x minus 5. So we must do the same to the numerator, to the top. We have to multiply the top, a, by x minus 5. Likewise, in order for the x minus 5 up here to become x plus 3 times x minus 5, we had to multiply it by the x plus 3. So we must do the same to the top, that is to the b. So it becomes b times x plus 3. Now this expression is equivalent to these two parts, but the purpose for doing this is that now we've got both fractions on the same common denominator, then the numerators must be equal. Since the fractions are equal, if the bottoms are equal, the tops must also be equal. So we write that down. Therefore, 2x minus 26, the top of the left-hand side, must equal the top of the right-hand side. And I've labelled this equation 1 because we're going to use it in a few different cases. So let's highlight that now. Whenever you get an equation that is likely to be useful later on in the question, we should number it and highlight it. So, how does this equation enable us to work out the values of a and b? It would seem that there are two unknowns but only one equation. No problem. The sneaky trick we use is we choose a value for x which eliminates one of the unknowns. And note here that if I replace x with 5, we'd have 5 minus 5, which is 0. And 0 times a eliminates the a, leaving us with only the b that we can solve. Likewise, if we choose a value of x to make the b disappear, that is, a negative 3, then we'd have negative 3 plus 3, which is 0. 0 times the b would remove the b and leave only the a, which we could then solve. And this trick can be used repeatedly no matter how many different parts a, b, c, d are in this equation. One equation can be solved for every unknown. How cool is that? Let's look at how we set it out. So, to determine the value of b, that's this one down here, we remove a by letting x equal 5 in the equation which we've labelled 1. So replace x with 5. So I'm going to take this equation and rewrite it, but we're replacing x with 5. The 2x becomes 2 times 5. 26, of course, doesn't change. The x here becomes 5. And the x plus 3 becomes 5 plus 3. And just as we intended, the 5 minus 5 in front of the a wipes this out completely. It's gone, leaving just the b. So the equation reduces to negative 16 equals 8b, which is of course solvable. Dividing both sides by 8 gives us negative 2. That's a key value. Highlight it, and let's move on to determine the value of a. So we do the same thing. To determine the value of a, we remove the b this time by letting x equal negative 3. Now why negative 3? Because down here we see the x plus 3 has to become a 0. So that means the x needs to be negative 3. And that will wipe the b out completely. Of course it'll still leave the a in place because negative 3 minus 5 will be negative 8, not 0. So replacing the x this time with negative 3 wherever it appears, 2 times negative 3, 2 times x, negative 3 minus 5, x minus 5, and negative 3 plus 3, which is of course 0, wipes out the b. So the b's gone, out it goes, leaving us with just negative 32 equals negative 8a. And of course this is solvable, giving us a equals 4. Another key value. Let's highlight it. So now we have the two key values, the b and the a, which we can simply substitute back into this original expression in step 2, and then we've got our answer. So we do that. Step 4, express the fraction as the sum with the correct values that we just calculated. So replacing the a, here we are in step 2, the a with 4 from here, and the b with negative 2 here, we have expressed it as the sum. But you might notice that whilst this is a sum, it's a bit cleaner if we take this positive and negative and rewrite it as minus a positive value. Looks a bit nicer. Either of these two would be accepted as solutions, but I like the last one better, so I'm going to highlight that to make it easy for whoever marks this question to determine where the answer is. If you do that when you're showing working, it's much easier for the person marking it to give you full marks. Make their job easy. So that's the end of this one. I hope you've found it useful. If you do, please subscribe to this channel, Ask Mr. Maths. Of course, you can also subscribe and check out my other YouTube channel, Ask Mr. Physics, which is just here. So check them out, please. I'd love it for you to subscribe to both or like the videos. And again, if you have any question in any maths or physics problem, please post it in the comments and I will make a video to address that question directly. Absolutely free. Thanks for watching. I'll see you next time.